This is the video for section 5.2 about the addition rule and complements. The objectives in this section are: use the addition rule for disjoint events, use the general addition rule, and use the complement rule. So objective 1 is use the addition rule for disjoint events. And events A and B are disjoint or mutually exclusive if they cannot occur at the same time. That is, they have no outcomes in common. They don't have any overlap. So here are a couple of pictures. In this picture on the left, the two events do have an overlap. There's something in their intersection that they both have in common. Whereas in this picture, there is no overlap. The two sets of outcomes are completely separate. So these two would be disjoint or mutually exclusive. And again, mutually exclusive says that if one is happening, the other one cannot be happening, so that they cannot both be happening at the same time. So the addition rule for disjoint events says that if events A and B are disjoint or mutually exclusive, then the probability of one or the other happening is just the probability of one plus the probability of the other. Since they're completely separate, we can just take the two probabilities and add them together. So again, here's our picture. We're just taking the probability of A and the probability of B and adding them both. Here's an example. Based on census data, the percentages of a certain state's population in 3 different age categories is shown here. Find the probability that a randomly selected state resident is either under 18 or over 65. So if we look at these two age categories, they would definitely be disjoint because no one could be in both categories. So if we name these as events, A being under 18 and B being over 65, those two events are disjoint. And that means to find the probabilities, we just need the probability of each one. So the probability of event A is 0.28, and the probability of B is 0.25. So to get the probability of A or B, we just add those two together and we get 0.53 or 53%. Objective 2 is to use the general addition rule. And this one can be used either for disjoint events or for non-disjoint events. And just to make this clear about the word or, we're talking about the inclusive or, which means either one or the other or both. So our notation is that the probability of A or B equals the probability that event A occurs or event B occurs or they both occur. Our general addition rule has to take this into account. So the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And this here is the probability that both events are occurring at the same time. When we're finding the probability that event A occurs or event B occurs, we want to find the total number of ways A can occur and the number of ways B can occur, but we have to find that total in such a way that no outcome is counted more than once. So what we're doing here is if we take the total number of ways that A can occur and add the total number of ways that B can occur, then this part in the overlap we've actually counted twice. We counted it once with A, we counted it again with B. So if we just add those two together, then since we've added this part in twice, we have to subtract the amount in that overlap to get the true value. And that's why in our general addition rule, we subtract the probability of A and B, because we've already counted it twice when we've added the probability of A and the probability of B, so we have to subtract it out once so that we're only counting it once. Here's an example. 1,000 survey responses are collected with the results here. Using these results and the empirical method to approximate probabilities for genders and age categories, we're going to find the probability that a randomly selected person from the population is male or over 65. So the idea here is that we would want to figure out our relative frequencies, and notice the males are divided into the 3 age categories. And then for over 65, we have the males and the females. So the total frequency for male in the survey results is our 3 age categories added together. So that gives us 511. And our relative frequency then is the probability of male. The probability of selecting a male is 511 divided by the total frequency, which was 1,000. So it's 0.511. Now the probability of over 65, we're just taking the 2 over 65 categories and adding them together, dividing by our total frequency, which was 1,000, and we get 0.315. There was a typo in my PowerPoint, sorry. The probability of male and over 65 is 113 divided by 1,000. And again, we need to calculate this one because that's the one that we have to subtract out. So our probability of male or over 65 is the probabilities of the 2 events added together. And again, when we add these 2 together, we're actually counting this one in the intersection twice. So we have to subtract it out once to account for that. So if we add the 0.511 plus the 0.335, subtract out our intersection, or our and that's 0.113, we get 0.713. Objective 3 is to use the complement rule. So first we need to talk about complementary events. The complement of event A, which in this class we denote by A with a superscript C, consists of all outcomes in which the event A does not occur. So in a way, it's the opposite of event A. If we look at the sample space, the complement of A includes all outcomes in the sample space that are not outcomes in the event A. So A and A complement together make up the whole sample space. Since it's impossible for an event and its complement to occur at the same time, that means that A and A complement are disjoint or mutually exclusive. So one occurring means that the other one cannot be occurring at the same time. Now we'll talk about the complement rule. An event that includes all the outcomes in the sample space has a probability of 1. Since A and A complement together make up the whole sample space, and they're disjoint events, the complement rule says that the probability of A plus the probability of A complement has to equal 1. So that's our complement rule. Some other forms of this rule, we can solve for either the probability of A complement or the probability of A. So basically, to find the probability of either one of these events, we just take 1 minus the probability of the other event. So the probability of A complement is 1 minus the probability of A, or we can find the probability of A by taking 1 minus the probability of A complement. And we'll actually use this rule a lot in later chapters of this textbook because in a lot of cases it's much easier to find the probability of the complement of an event than it is to find the probability of the event itself. And again, here's our picture. Here's our whole sample space is this box. And we've got the A complement and the A, which if we put those together, they make up the whole sample space. Here's an example. In an article about investment growth, Money Magazine reported that drug stocks show powerful long-term trends and offer investors unparalleled potential for strong and steady gains. Many individuals age 65 and older rely heavily on prescription drugs. For this group, 82% take prescription drugs regularly, and this is from Money Magazine in September 2001. What is the probability that a randomly selected individual age 65 or older does not take prescription drugs regularly? So if we look at this, if A is the event that a randomly selected individual over 65 does take prescription drugs regularly, then A complement is the event that the individual does not take prescription drugs regularly. And notice that we would have information about the event A, but we don't have information about the event A complement. So we would know that the probability of A is 82%, or 0.82, and we can use that to find the probability of the complementary event by just subtracting that probability from 1. So the probability of A complement is 1 minus 0.82, or 0.18, or we could say 18%. Here's another example. If we go back to the probability experiment of rolling a die, let event A consist of rolling a 5 or more. Find the probability of A and its complement. So our event A includes two outcomes. We could write this as a set, so A is equal to 5, 6. These are the two possible outcomes in our event. Our sample space is all the different faces on the die, so it's the numbers 1 through 6. And that means the probability of A, remember, is the number of outcomes in the event divided by the number of outcomes in the sample space. That's 2/6 or 1/3. So the complement of A includes all the other outcomes in the sample space that were not included in A. So A complement would be 1, 2, 3, 4. That way, if we put A complement and A together, we would get the whole sample space. So the probability of A complement is 1 minus the probability of A, so it's 1 minus 1/3 or 2/3. Now, another way that we could find this probability would just be to look at the number of elements in A complement and divide by the number of outcomes in the sample space. So we have 4 outcomes in A complement, and we could divide that by the number of outcomes in the sample space, which was 6. That would give us 4/6, which also reduces to 2/3. So we would get the same answer either way.